Solve the equation of 6 tan theta plus 8 equals 0 for theta to the nearest degree, where theta is greater than 0 but less than 360 degrees. To solve this problem, we want to use our 4 steps below, where step 1 is to solve for our trig equation. In the question, we're given an equation of 6 tan theta plus 8 equals 0, but we want to isolate for tan theta. So we first subtract 8 from both sides, and we have 6 tan theta equals negative 8, and then we divide both sides by 6 to give us tan theta equals negative 8 over 6. Now that we've solved for tan theta, we want to identify the quadrants that this is in. As we can see, our ratio of tan theta is negative, which means we want to use the quadrants where tan is negative. Well, looking at our 4 quadrants, the 2 quadrants where tan is negative is in quadrant 2 and in quadrant 4. In quadrant 2, only sine is positive, and in quadrant 4, only cos is positive, making tan negative in both quadrants. Now our next step is to find the reference angle. Remember, the reference angle is the acute angle between the terminal arms and the x-axis. So we have our reference angle in quadrant 2 and in quadrant 4. And we want to find the value of this reference angle. To do this, we need to use our equation of tan theta equals negative 8 divided by 6. Because we're not using exact values, we need to use a calculator to solve for theta. So to find theta, we take the inverse of tan of our positive ratio, 8 over 6. Now plugging this value into our calculator, we get an answer of 53 degrees rounded to the nearest degree. So let's replace this in our picture. Instead of our reference angles, we found that they have a value of 53 degrees. Now our next step is to use the graph to find the solutions. So in our graph, we have terminal arm 1 and terminal arm 2. And we want to find the standard position angle from 0 degrees to terminal 1 and 0 degrees to terminal 2. We'll label our first angle theta 1, and we'll label our second angle theta 2. So let's start by finding the value of theta 1. To do this, we want to take the difference of 180 degrees from our x-axis and our reference angle of 53 degrees. Now subtracting these two numbers together, we get a rounded answer of 127 degrees. And looking at theta 2, we can see that our angle passes 180 degrees, but just cuts short of 360 degrees. So to find theta 2, we have to take 360 degrees from our x-axis and subtract that from our reference angle of 53 degrees. And we're left with theta 2 equals 307 degrees. So we found that theta 1 in quadrant 2 equals 127 degrees, and theta 2 in quadrant 4 equals 307 degrees as our final answer.